Thank you. Good day, everyone. My name is Sven Konings, a commercial manager at TSC Silos. And in my job, I come across in a variety of industries, several feed and food building design questions, so to say. So the topic of today is how structural thinking improves your building design. Of course, today we've seen a lot of movement in my presentation. We won't. In this presentation, a little bit on TSC, what we do, essential information on square silos and engineering a mill structure, how we approach it, and how we program our silos nowadays. TSC Silos, we've celebrated our 25th anniversary last year. We do 35 to 40 projects per year worldwide, and we focus really on square silos and the related steel structures only. We have all engineering capacities in-house, meaning we are with 24 colleagues focusing solely on the square and rectangular silos. Some essential information on square silos. They're modular, tailor-made, flexible design. There is no standard. It is quite obvious the most efficient use of space. And important is that can be structurally integrated into your building, meaning the silo is part of the building. It's designed for its cost, low maintenance, long life. It fits the ingredients, the raw materials, or the finished product that goes in. And which is very important, and we'll continue on that, is as built means it's as designed is as calculated, or the other way around, whatever you like. Because engineering a mill structure is designed with the process in mind, but also usability. What is more and more important nowadays is that it comes down to being able to take account of what is built. Design documents that can be checked, verified and replicated, because it's a trend we see more and more and more. Every building faces more scrutiny from legislators, so they want to be able to check what you do, what you build, and what you see is what you get in our case. So that's really a focus area for us. So general approach. Typical approach nowadays is that we start often with a flow diagram, of course, today's topic as well, and that follows an initial building design up to an architectural design. And well, my topic of today would be that add structural pre-design in that pre-engineering phase as well, because it will save you a lot. Said also by Sebastian, for example. The cost of changes in an early stage are far less than changing at a later stage, especially during construction, of course. How would that look like? Typically, you go from a 2D side drawings, top drawings, to a 3D architectural drawings, and we say add these loads. At these structural engineering in an early stage, because the loadings are very important for the rest of your project. We can check for collisions already with the initial machinery, remove errors, remove mistakes, and we calculate the footloads, which means by these footloads the foundation can already be designed, meaning you can, after an order, after a go moment, the supplier of the foundation can already go on with the project quite soon, saving you a lot of time in that area. So, to consider when designing a building, we design it as lean, as mean as possible, but changes have impact. Every machine has its own loads. And when footloads are calculated and finalized, that basically is a point of no return. Changes then have a specifically increased impact. But it also means that cleverly connecting the silo with the structure leads to a lighter yet more cost-efficient structure with a usable and efficient design. And why does it matter? Because we go into every single detail it is calculated like this, it is designed like this, and as designed, as I said, is as built, which the lower images perfectly show. So to sum it up, create a lean yet mean structure means involving a structural designer from early on. Make sure everyone involved is aware of what changes do to the process, but also, of course, to a building. So that awareness would save you in total lead time of a project. Some case-specific solutions, of course, there are the obvious solutions of the obvious advantages of approaching a project like this. Maybe it's also nice to show you some recent solutions we provided, which are, if you are not aware of them, they are far less obvious. So in this case, the customer asked us, as the concrete supplier couldn't do it, to provide a base for an air filter that would normally stand outside. You see it's a concrete building, and we helped the customer by making a suspended floor, hanging it onto the concrete structure. The air filter could be placed on site, and as an extra benefit, it was an easy, accessible platform from the top of the silo, so maintenance could be performed very easily in case necessary. Another nice one is a staircase that stood in the way, but it was a necessity, the staircase, because of fire regulations. So here you see the ground area, and when the customer saw this 3D design, he noticed that the one upright of the staircase wasn't so positioned well for his trucks driving around this area. So he asked what can we do about it, and then we came up with this cantilever structure connected to the silo, structurally connected to the silo, so removing that area, making for a lot more space for the trucks driving around. And in real life it looked like this, saving valuable space. Nice other one was a bulk truck loading street. There was an existing facility. We came on site, and customer had its desire to connect it to the existing structure, the new bulk truck loading street, to connect it to the existing structure. But there wasn't a structural calculation available. By the age of the silo, we had our doubts about the structural integration, so we decided to solve it another way around, not by connecting it, but by making a suspending floor basically over the existing facility, making the roof stand out, which, well, by design looks like this, and in reality looked like this. So the silo perfectly falls over the existing bins, connects, is not structurally connected, but is connected in a way that still makes for a workable environment. Even the falling pipe from the existing from the facility down to the trucks was taken into account in this snippet. You can see so. Also, with architectural design and an increasing scrutiny from legislators, we come more and more across that the outside must look appealing too, which of course has also its impacts sometimes on building designs, and not in a way you might expect. So here we have provide railings for cladding to the building, and you see that these railings are placed at intermediate levels. So what does that look like in real life? You can see it in the pictures. Cladding at intermediate levels, so you can have a building that is designed like this, with, well, falls in nicely into the landscape. Maybe I'm not sure what the reason was, but it looks quite nice. It's all structural, so we're a silo company. So what about silos? Well, silos, to be honest, take up less and less of our time. We are now in a stage of highly automated engineering with self-made calculation tools and plugins for our software we use. There are a lot of parameters, of course, that come into play when designing a silo. It's all put into a program in Excel calculations, and we put those parameters to work, and with that comes a structural design, a structural basis, for the design. Goes for the wall panels of the silo, of course. Also for the hoppers, the principle is the same. Just the it looks a bit different. So you go from silo parameters to loads on the hoppers, and what that leads to is what I call nowadays we do not do any engineering anymore. It doesn't want to start. We've made the connections between these Excel sheets. Yeah, thanks. And full disclaimer: this is speed ×2, real time, but it's just a screen take from an engineer of us making a silo with 4 different bin dimensions. In the past, silo was of course an important part of our daily job, and nowadays it's highly automated and also takes up less and less of our time. It's now a matter of minutes instead of days that we're talking about. This is a live plugin working with Excel. We calculated with. This communicates, it's a preset, it loads into the plugin and that loads into the design software we use. Every single wall panel is calculated, every single hopper is calculated, and it communicates in case changes are being made. And that's why engineering of square silos nowadays takes up less and less of our time. It might be nice to have this one. And you see specific details, but every element is specifically calculated for its position. You see in this example very nicely the reinforcements on the inside of the wall panel. They are also based on the Excel sheets, and they are put in place by the design software according to the position as meant to be. Sure. Yeah. Oh, now it works. So improve your building design by adding structural thinking early on, because it increases certainty to the rest of your project. It saves on your lead time. It increases the usability of your building, and it might even fix issues you weren't even aware of at this stage. Thank you for your attention, and in case you'd like to talk further, please visit us. Stand D001. Thank you.